Lesson 20.1, Task 3. Choose an exponential model. Unlike new cars, which usually decrease in value in the years after they are purchased, a classic car can increase in value. The table shows how the value of one classic car has increased since it was purchased by a car museum. Find a function that models the data well, then use the function to predict the car's value 50 years after it was purchased. Now, obviously, for an antique car, they have to be in good condition to increase in value. You can see the picture here. This one has no rust on it. It looks like it's new. It's just really old, but it's been kept in good shape. So it doesn't have to be perfect, but the better shape it's in, the more value it's going to be. All right, so this has time in years. That's our X. And value is in thousands of dollars, and that's our Y. So those are our ordered pairs from our table. So it says make a scatter plot of the data and use regression to find a good model. All right, so I've already entered the data in my calculator just to kind of get us moving a little bit quicker. So these are the points from the table above, and it says make a scatter plot. So once again, I'm going to make a scatter plot. If I hit graph, oh, well, I need to get rid of some of this other stuff first. Let's clear this out and hit graph. All right, so you can see these are our points, but I need to look and see if I've got my table set up to where I'm seeing all of my points because I didn't change the window yet. So if I change the window, I know this is going to go from 0 to 40 on my X's. So my X's go up to 80, so that's good. We can actually change that a little bit. Let's make that 50, I guess. And going by fives is fine because these go by fives. And then let's make our Y values. It goes from -2 to 35. Our Y's need to go from 5 to 35. So it was showing pretty much all of our information. And I hit enter. And let's change these to maybe from 5 to 35. Let's go by 2s instead of 5s. There's no perfect thing you have to do for your window there, but the more accurate you change the window to match the data that you have, the better image, the better picture graph that you're going to see. So you can see that this does look like an exponential model. It could also be quadratic, but it's not going to, increase on the other side here. So this does look like an exponential model. So let's see what the rest of this says. All right, so it says make a scatter plot of the data and use regression to find a good model. Enter the data pairs into a graphing calculator and make a scatter plot. The data plots clearly follow a curve rather than a line. We could see that. So a linear function can be eliminated as a possible model. The coefficient of determination for an exponential model, r squared, is about 0.9996. So that's a very good model for exponential. Is slightly closer to 1 than for a quadratic model. Also, the growth in the value of an appreciating asset is typically expressed as a % increase per year, which supports using an exponential model. Therefore, a good model for the data is y equals 4.96 times 1 plus the 5% increase, so 1.05 raised to the x power. We know that's an exponential equation because x is your exponent. And so it says that that is the best model. So now it says predict the car's value 50 years after it was purchased. Find the value of y when x is 50. So all we have to do is plug 50 in for x. Well, here's our model. We know that x was the exponent, so we have to evaluate this to the 50th power and then multiply. Order of operations is so important. If you don't do order of operations, you will not get the correct answer. Your calculator may be able to enter all of that at the same time and get the correct answer, but I'm going to do 1.05 raised to the 50th power first, because you do exponents first, and then multiply that by the 4.96. All right, so 56.87, 56.9 about, is what we're going to get for a y value. So let's change this over, or let's do this in a different way. Let me see if it will work. 4.96, parentheses 1.05, raised to the 50th power. What I'm checking is to see if you get the same answer. Does your calculator use order of operations? In this case, it did. Okay, so the calculator did it correctly by simply plugging it in. So 56.9 is about $56,900 is what the car is worth after 50 years. If you remember, the table said the value is in thousands of dollars. Time in years, value is in thousands of dollars. All right, and it shows this graphed on your calculator here. So it says use a calculator to find a quadratic function that models the data set, then select the words and value to correctly complete the statement. A quadratic model. Okay, let's look at a quadratic model first. All right, so if we already have our points in there, I better check. Okay, our points are in here. So I'm going to go to Stat, Calculate, and I want to find a quadratic model. And it says r squared is about 0.998. So this is a good fit, okay? This one was about 0.999, so this one is a better fit, but your quadratic model is a good fit. So it says the quadratic model is a good model for the data because the value of r squared is close to 1. So even though the exponential model is better, it's only slightly better because this one is very good model as well. Okay. All right, so it says select the phrases to correctly complete the statements, comparing the values of the classic car predicted by the exponential and the quadratic model. All right, so initially the value of the car predicted by the exponential model is less than the value predicted by the quadratic model. So when you very first start, the exponential starts lower, it is less. After 5 years, the value of the car predicted by the exponential model is greater. So the exponential model does pass it. So the value predicted by the quadratic model. As more time goes by, the difference, okay, we're looking at the difference in the value of the car predicted by the exponential model and the value of the car predicted by the quadratic model, they will get further apart. So the difference would increase between those two models. All right, so there in this example, we had two very good models. We had to choose the one that was closest. So in this case, the exponential model was closest to predict the value of a classic car. All right, so that's all for task 3. If you have any questions, let me know.